All right, at the bottom of page 5, I have the steps for the substitution method outlined. So let's go ahead and read through those and then we'll try some problems. Step 1, you're going to solve for one variable. You're going to choose one equation and solve for one variable in terms of the other variable. Okay, and there's a little hint there that says make a choice that avoids fractions if you can. Okay, second step, substitute. Substitute the expression you found in step 1 into the other equation. That's important. You need to substitute it into the equation you haven't used yet to get an equation in one variable and then solve for that variable. Okay, and then the third step is to back substitute. Substitute the value you found in step 2 back into the expression found in step 1 to solve for the remaining variable. Okay, so let's go ahead and try this out. All right, so in example 3, okay, we have 4 different systems of equations, and we are going to solve each system of equations using substitution. Okay, all right, so our first system in example A, first equation is y equals x minus 4. The second equation is x plus 3y is equal to 12. All right, so I'm going to kind of write out the steps here. So the first thing you want to do is pick one of the equations and solve it for one of the variables, okay? It doesn't matter when you do this. It doesn't matter really technically it doesn't matter which equation you pick or which variable you solve for. There might be an instance where one equation's easier to work with and, also one of the variables might be easier to solve for, okay? So let's go ahead and write this down. Step 1, we're going to solve for one variable. All right, well, when I look at this, if I look at equation 1, okay, so equation 1 here, it's already solved for y, okay? So I don't have to really do anything. I'm just going to choose that equation. We know that y equals x minus 4, okay? If this equation, or if neither equation had been solved for either x or y, we would have had to do that. But here, the first equation is already solved for y, so we're just going to use that, okay? So then the next step that we're going to do is we're going to go ahead and do the substitution step, okay? So I am going to take this result, which was obtained from the first equation, and I am going to plug it into the equation I haven't used yet. I haven't done anything with the second equation, so I'm going to go ahead and write down the second equation, okay? And now we're going to substitute this result, okay? So what this means to substitute, everywhere you see a y over here, you're going to replace it with x minus 4 because we know that y equals x minus 4. All right, so let's try it. So we're going to get x plus 3 times, instead of multiplying by y, we're going to replace y with x minus 4, okay? Now, x minus 4 is a package deal, so you need to have parentheses around it because you're going to have to distribute that 3. You're multiplying y, which is the same thing as x minus 4, by 3, okay? All right, and so that equals 12, okay? So again, all I did was go to this second equation. Everywhere I saw a y, I replaced it with the package deal x minus 4, okay? The reason this is great for us is because now we have an equation that just has an x, okay? So we can solve for the x value, okay? So let's go ahead and do that, okay? So we're going to get x plus, you're going to have to distribute here, okay? So we're going to get plus 3x minus 12 is equal to 12, okay? Come over here. All right, so let's keep solving. We can combine like terms. We're going to get 4x on the left minus 12 is equal to 12. All right, so we've got to get x by itself, so let's add 12 to both sides. So we're going to get 4x is equal to 24. Divide by 4. We get that our x value has to be 6. Okay, that's it. Okay, so that's the x value. Okay, you have to do one more thing because we're not done yet, because you need the y value as well. Okay, so now we need to use the fact that x is 6 to get the y value. Okay, so the last step is what they call back substitute. Okay, so what that means is, go back to, you know, one of the original equations, it doesn't matter which one, or go back to this over here and plug in x equals 6 to get the y value, okay? The easiest thing to do is to use this because this tells us how to get y, okay? So we know y has to be x minus 4, okay? And we also know that x is 6, okay? So we'll go ahead and substitute that. We know x is 6. All right, so that means y has to be 2, okay? So there we go. The solution to this system is x equals 6, y equals 2. Okay, so remember, you can either spell that out, okay, or you can just write it as an ordered pair, but x would have to go first. So this is going to be 6, 2. Okay, and that's it. That's how substitution works. Okay, all right, let's try another one. All right, so in example B, okay, here's our system. We have 3x minus y is equal to 7, and then we have 2x plus 3y is equal to 1. Okay, so neither of these equations is already solved for one of the variables. Okay, so what you need to do in step 1 is pick one of the equations and solve for one of the variables. Okay, so we're going to solve for one variable. All right, so you know, it doesn't matter which equation you pick. It doesn't matter whether you solve for x or y, but you want to try to be smart about this. Pick something that's, you know, the easier way to go where you won't get fractions involved if you can avoid that. Sometimes you can't. But if you look at equation 1, okay, if you took equation 1 and solved it for y, okay, that wouldn't, you know, introduce any fractions, okay, because the number in front of y is a -1. It's a 1 coefficient. So that's kind of why there will be no fractions. So what I will do, okay, I will go ahead and take the first equation and I'm going to solve this guy for y, okay? So I want to get y by itself. So I'm going to go ahead and subtract 3x from both sides, okay? So I'm going to get -y, be careful, make sure you bring that negative sign, is equal to -3x plus 7, okay? Divide everything by -1, okay? And so we're going to get that y is equal to divided by negative is positive 3x. Positive divided by negative is negative, okay? So there we go, okay? So the first equation has been solved for y, okay? You could have solved it for x, okay? But that would have introduced a fraction, which is fine. It's just more of a pain to work with, okay? All right, so let me kind of partition this off so I have enough room. All right, so the next thing we're going to do is plug in this result into the other equation, okay? So remember, we got this information from equation 1, okay? So now we have to use the other equation, okay? So what we're going to do now is substitute, okay? All right, so we are going to take the other equation. If you don't use the other equation, it's going to get you back to where you started with, and you're going to end up confused, like, why isn't this working? You have to use the equation you haven't worked with yet, okay? All right, so here's our other equation. We're going to substitute this result. So everywhere we see a y, we're going to replace it with 3x minus 7, okay? So we're going to get 2x plus 3, okay? Instead of multiplying by y, you're going to multiply by the package deal 3x minus 7, okay? All we did was replace y with 3x minus 7, okay? And then that has to equal 1, okay? So all I did was go to the second equation. Everywhere you saw a y, replace it with 3x minus 7, okay? We are left with all x's, okay? So we can solve for x, okay? So we're going to get 2x plus, don't forget to distribute, plus 9x minus 21 is equal to 1. All right, combine like terms. We're going to get 11x minus 21 is equal to 1. Okay, I'm going to go over here. Okay, I'm going to get, let's see, I'll go ahead and add 21 to both sides. Okay, so we'll get 11x equals 22. Divide both sides by 11. you get that x is 2. Okay, so that's it for x. All right, and so last step, we just need to back substitute. Okay, and that is just a fancy phrase for saying, all right, I know x is 2, use that information to get the y value. Okay, again, I can take 2, x equals 2, I can plug it into either one of the original equations. It doesn't matter which one you pick. You'll and solve for, plug it in and solve for y, you'll get the same answer. But the easiest thing to do is use what you got from step 1. You know how to calculate y. Okay, so we know y is going to be 3x minus 7. Okay, plug in the fact that x is 2. So we're going to get y equals 3 times 2 minus 7. So that's going to tell us that y is 6 minus 7, which is negative 1. Okay, so that's what y equals. Okay, so there is our solution to the system. X has to be 2, y has to be negative 1. Okay, so I'll go ahead and write it here as an ordered pair. So x has to go first and then the y coordinate. Okay, and again, if you plug this variable assignment into, either one of these original equations, you should get a true statement. Okay, all right.